Hey guys, so today's lesson is on factoring polynomials using the greatest common factor, the GCF. I do want to welcome you guys back from spring break. I hope you enjoyed your time off and you didn't do schoolwork and you took the time to relax and spend some time with your family. I didn't check emails. I didn't really do any work myself, to be honest. I felt like I needed to do the same. So if you emailed me, I'm trying to get back to you as soon as I can. Okay, so there are three steps in factoring polynomials. The first one is to find the greatest common factor. That's also known as the GCF. So you want to find the greatest common factor. Step two is to divide each term by the greatest common factor. And then when you're done, step three is to write your answer with the greatest common factor outside of parentheses. Okay. Okay, so we're going to work on some problems there from your skills practice. And the directions say factor out the greatest common factor of each polynomial if possible. So again, I'm just going to do the odd problems. The even ones are what you're going to do as practice problems and turn those in. Okay, so the first one, you have x squared plus 9x. You're given a polynomial, and we want to factor using the greatest common factor. All right, so what you can do, and you don't have to, I'm just going to show you for this problem. X squared is really x times x. Okay, that's the first term. And the second term is 9x. Okay, so which is the same thing as 9 times x. So what you want to do essentially is look at your factors and see what they have in common. Okay, so for the first one, I have two x's. For the next one, I have a 9 and an x. So I know that they both have an x in common. So that x is my greatest common factor. So on the side, I'm going to just say my GCF is x. Okay, so let me go back to my problem. I'm going to rewrite it x squared plus 9x. And what I'm going to do is I'm going to divide by my greatest common factor. So I'm going to essentially pull an x out of each. All right, so what I have now is I'm left with, if I have two x's here and I pull one out, I'm left with 1x. Another thing you could do is subtract your exponents. The one in the denominator right now is doesn't have one, so it's just a 1. So 2 minus 1 is 1. So I'm left with an x plus. For the second one, your x's cancel. Okay, so I'm just left with 9. Now, again, remember step 3, you want to write your GCF in the front. So put it in the front and then put whatever you're left with in parentheses. So this here is my answer. It's x times x plus 9. We factored it using our greatest common factor. This here is your GCF. It's included in your answer. Okay, let's move on to number 3. So for number 3, I'm going to write it out. You don't have to. I'm actually going to do it on the side. So my first term is 5x squared. Okay, 5x squared could be written as 5 times x times x. The second term is 20x. Okay, now 20x could be written as 5 times 2 times 2. Okay, and I got that from I thought of the prime factorization of 20. So I know 20 is 5 times 4, and I know 4 is 2 times 2. So all of these numbers create the prime factorization of the number 20. So I just wrote those out. And then I'm going to write times x. And then my last term is 15. Okay, so minus 15. So for 15, that's going to be 5 times 3. So I'm going to put 5 times 3. Okay, now if I look at each one separately, you want to look for the greatest common factor. Okay, so what do they each have in common? Now the first two have x's. Okay, I could pull out an x here and an x here, but I don't have an x at the end, so I can't use that in my GCF. It has to be something that they each have. Now by looking at it, I can tell they each have a 5. Okay, so there's a 5 that I can pull out for each, so that's going to be part of my GCF. But there's nothing else I can pull out. Here I have 2 x's, here I have 1 x and 2 2's, and here I have a 3. Okay, so my prime factorization is going to look like this. So what I'm going to do is take my GCF, which is 5, and divide that to each term. I have 3 terms. Okay, Honestly, this negative here by the 15, you don't worry about it right now. You'll just see it in your answer. It's not a big deal. Okay, so for each one, divide by 5. Okay, so for the first one, the 5's cancel. So I'm left with x squared plus 20 divided by 5 is 4. So 4x minus, and then 15 divided by 5 is 3. Okay, now this would be my answer. I just have to put this in parentheses and then put my GCF outside. Okay, my GCF was 5. All right, so this is my answer. Okay, and then remember to put your GCF outside. You don't have to draw an arrow saying GCF. You could if you want to, but I'm just doing it to show you. All right, couple more. Next one, number 5. So we have y cubed minus 7y. You could break this down. So I could say, oh, well, y cubed is y times y times y. And then I could say 7y is just 7 times y. And then you can see that they both have a y in common. And that's it. That's all they have in common. So your GCF here is going to be y. Okay. Now, you can also look at this and say, well, in the first term I have 3 y's. The second one I only have 1 y and a 7. So I know my GCF is y. You don't have to write this out every single time. So I'm going to take each term, divide both of them by y. So after doing that, I'm going to get y cubed divided by y. You essentially subtract 1 from the exponent. So here, remember, I have 1. So 3 minus 1 gives you 2. So it's going to be y squared. I'm left with 2 now, minus 7. And then my y's cancel because they're exactly the same. So I'm going to get minus 7. Put that in parentheses. Your GCF goes outside. So this is my answer. It's y times y squared minus 7. All right. Last one, we have 3. Actually, no, it's not the last one. We have 2 more. Next one, we have 3w plus 10. So now just looking at my 2 terms, I have a 3w and I have a 10. Now 3 and w, they can't be broken down. 3 is prime, w is just w. On the right though, the 10 could be broken down. The 10 is essentially 2 times 5. All right. Now, if I did, break it down on the side, so I have this, and then I say, oh, well, this is 3 times w, 10 is 5 times 2. You would see that there's nothing that they have in common, okay? I have a 3 and a w, but I have a 5 and a 2. So I don't have a GCF, okay? I guess you could say my GCF is 1. You could divide anything by 1, but that's not going to change anything for you. So for this one, I would just leave it as 3w plus 10, okay? That would be my answer. You can't factor it. It's already factored. Okay, number 9, we have 7m cubed minus 21, all right? So for this one, I'm going to move it over to the side. I have 7m cubed, and then I have 21. Okay, so 7m cubed is 7 times m cubed is m times m times m. And then 21 I know is 3 times 7. Okay, so then by looking at this, I notice they both have a 7 in common. This one has a ton of m's, but this one does not. So my GCF is 7. All right, so over here, I'm going to divide by my GCF, which is 7. 7 divided by 7 is 1. You could put the 1 there. You don't have to. I'm just going to write it for now. So it's 1m cubed minus, and then 21 divided by 7 is 3. Throw it in parentheses, and then put your GCF outside. Okay, so it's 7 times 1m cubed minus 3. Your answer could also be 7 times m cubed minus 3. You don't need the 1 there. Okay, but if you have it, it's fine. Not a big deal. All right. That's it, you guys. Let me just go back to the beginning and reiterate your steps. So the first one, find the greatest common factor. Step 2, divide each term by the greatest common factor. And then step 3, make sure you write your answer in parentheses and then throw that greatest common factor on the outside. So for homework, you have the even problems. Make sure you do those and then email me if you have any questions. Bye.